Hey guys, welcome to my math corner. So today we're going to talk about polynomial. First of all, I would like to briefly introduce the concept of long division. So for long division, we can easily see that, for example, if you want to divide these expressions, so you will see cube expressions very often in this chapter. So how can we do that? Right, so here is the fundamental procedure in solving this equation. Right, okay, look at the right hand side. We just copy the expressions here. And then we use this symbol to represent long division. Okay, and what should we do? Usually we can just directly solve it. But right here you can discover there is a square term missing, right? So in this case, we need to add the square term. Okay? That is the easiest way. We won't get confused. So no matter whatever you see there is a term missing, no matter it's square or it's power to the 1, we always add the term in the long division. Okay? Right, now let's do it. And please remember, you should always make this coefficient equal to this coefficient at the start. So what do? We multiply by 2x to the square. Okay, why do we write this quotient here? Because we need to match. Okay, so what we need is x squared, so that it can be x cubed after multiplying this one, right? And it should be in the place exactly on this one, okay? And if you multiply x to the power 1, where should it be? It should be this place, right? And for the constant term, you should write this term, this place, this position. Okay, then it equals to 2x to the cube, perfectly matched. Then plus 6x squared. Okay, so 3 times 2x squared equals to 6x squared. So that's the reason why you should always add the missing term here. Because if you do like this way, you don't add the missing term, then you will find the 6x squared will be in the position right here. So you cannot do subtraction in this case. But here, because they are the similar term, the same type of term, because the power of x is equal, so we can easily do subtraction. Okay, and subtracting them equals to negative 6x to the power 2. Okay, always use the upper term minus the lower term. But what if the lower term changes into negative? For example, I change this term into negative 6. Is that the answer still negative 6x squared? No. Okay, because 0x squared minus negative 6x squared equals to 0x squared plus 6x squared. Okay, so in this case, the answer should change to positive 6x squared instead of the original negative one. Okay, right? So always remember it's subtracting. And when you encounter negative terms, please remember to bracket it. Okay, use the bracket to avoid any mistakes. Okay, now let's move on. So for this one, that's the answer what we are looking for, right? And then what do we do next? We copy the next term down here. That is, okay, that is negative x. And we still need to match the first term coefficient equal. Remember, when you do long division, always equaling the first coefficient. In this procedure is the 2. In this procedure is the negative 6. How can we match? Is the negative 6, right? So negative 6 multiplied by x equals to negative 6x. Is that correct? Oops, there's still a x missing, right? What's the problem here? Firstly, a constant term should not be written here because this position should be written with power to the 1x. Okay, so negative 6x. And then we can see it's negative 6 squared after multiplication. And then it's 18x. So negative x subtract negative 18x equals to negative x plus 18x equals to 17x. Okay, 17x. Right, 17x plus 51. And how can we do that? We still plus or minus. It's minus, right? Because we need to match the coefficient here. The coefficient is negative 17. So it's minus 17 equals to negative 17. And minus, okay, minus 51. So I hope you guys can understand the procedures here, okay? Right, and is there anything wrong with the answer? Yes. I don't know if you guys has discovered the negative sign should be changed to positive, okay? Because it's positive 2 times positive 3 equal positive 6. So we need to change the following sequences. This one and this one. So it's this one, okay? Oops, okay, so we need to plus, okay, plus 6x equals to positive 6x squared, and then it's plus, okay, so it's positive 17, and then it's positive 17, it's positive 51. Then the answer should be 0, no remainder. In this case, no remainder. Okay, so the answer is very obvious. You can see the quotient is this expression, the square, the quadratic expression. Okay, so I give you guys an example here. What if I give you a question like this? 3x squared minus 50x plus 8 divided by 3x square, oops, this one is cube, okay, 3x cube plus 12x minus 2. So please solve the question, okay? And then if you really want to compare your answers with mine, you can leave your comments, let me know. Okay, next one. We should talk about factor theorem. Before talking about the factor theorem, we should know that there are two symbols quite similar. Actually, they are equal, they are equivalent. The first one looks like this. Second one looks like this. Okay? So in this case, they are equal. They are telling the same story. So no matter which one you encounter, don't be confused. Okay? If you are more familiar with this expression, you can always turn this one into this one. Right? And we call the highest power in an expression degree. So this is a specific term, degree. We use this word to express the highest power. The highest power in an expression. For example, in this expression, the highest power or the degree is 3, right? And for this expression, the degree is 2, okay? And so on. So why should we recall this concept? Because if we, so for example, px represent 3x to the power 4 plus 2x squared minus 1. Okay, in this example, the degree is 4. Okay, what if we make the expression square? So it equals to this one. And we want to find the degree afterwards. So after squaring the whole expression, okay, after squaring the whole expression, what is the new degree? The new degree should be 8. How can I find out the new degree so quickly? Because if we using the brackets, then totally squaring, and then you will find that the degree will be determined only by the original degree. Okay, so you just need to use 2 times 4 equal 8. Okay, so that is the new degree. Because all the other power will not affect the new degree. We only want to find the highest power. Okay, so the conclusion is that if the small p is the degree, then p squared equals to 2p. Okay, equals to 2p. In this case, p equals to 4, so the new p equals to 8. Simple as that. Okay, next thing. Actually, we can see if we combine two expressions, so gx and fx. Right, gx equals to 3x to the power 4 plus 2x squared minus 1. And fx equals to x cubed minus 5x squared plus 8x minus 4. Okay, what about gfx? If I combine the two functions together, what would happen? Then what you need to do is that you bring the whole fx expression into each x in the g expression. Okay, so in this case is 3 bracket x squared. Okay, so I can write in this way, 3 fx to the power 4 plus 2 fx to the power 2 minus 1. And then what you need to do is you bring the whole expression here into the bracket, and then power to the 4 and then power to the 2. That's it. But what we do it reversely, if you write this way, then we do the opposite story. Okay, we bring the whole g expression into each x term in the fx, and then accordingly or respectively you go to the power, different powers. Okay, right. And next thing, so we are going to talk about factor theorem. The factor theorem. So what is the factor theorem? The conclusion is that, so for polynomial px, if p c equals to 0, then x minus c is a factor of px. Why should this happen? Because actually we can use an example to illustrate. So basically we use the expression here. So you can see this expression x plus 3 is a factor of this expression, right? Because after dividing, after the long division, we can find that there is no remainder, which means it will be exactly divided by this one. That's why this one is a factor of it. Clear? Okay, now what if we let x equals to -3? Okay, x equals to -3. Bring this value into the upper equation here. You will find that 2 times -3 power to the 3 minus -x plus 51. Then it equals to negative 54 plus 3 plus 51. Okay, it equals to 0. Okay, it equals to 0. So -3 will make the whole equation value equals to 0. So we say that x minus -3, this one is a factor of the polynomial, and x minus -3 is equal to x plus 3. Okay, so this one is a factor of the polynomial. So whenever you find out there is a value that will make the whole equation equal to 0, then you use this expression, it's a factor of it. That's the factor theorem. Vice versa, okay, if you do reversely, for example, if the question tells you want to prove whether x minus 2 is a factor of the polynomial given, you don't have to do the long division to prove it. You just need to make the factor equal to 0, then x equals to 2, and bring this 2 value into each variable term. Then if the whole equation becomes 0, it's a factor. If not, then it's not a factor. Simple as that, okay? Right, that's the factor theorem. And we can extend this theory into more common ways of expressing it. So for polynomial px, if p b over a equals to 0, then ax minus b is a factor of the polynomial. How can we do that? For example, if x equals to 3 over 2, okay, we'll make the whole equation equals to 0. Should we write x minus 3 over 2? It's not that the common way we usually write. We usually write, okay, so what is the common way we write it? We write 2x minus 3. Okay, 2x minus 3. And when x equals to 3 over 2, 2 times 3 over 2, when 3 equals to 0. Okay, so we usually don't write fraction. Instead, we write integer expression. So that is this statement talking about. Actually, it's the same. It's the same for this one. You just need to memorize this one. That's okay. Okay? Right. And next one, we should take a look at the cubic expressions and equations. So how to solve cubic equations? How to solve cubic equations? So for cubic equations, for example, f(x to the power 3x cubed minus 3x squared minus 13x plus 15. Okay, so in this case, we need to find out how can we factorize. Okay, we need to factorize this equation into lower power. How can we do that? So there is only one way we can do this. That is, we use the constant term. It's called by trial and error. By trial and error. Okay, by trial and error. What are the factors for the constant term? There are positive or negative 1, positive or negative 3, positive or negative 5, positive or negative 15. Is that all? No, we should not stop here. There are still more. Okay, we have negative 1 over 1 that is negative or positive 1, and positive or negative 3 over 1. Okay, so simply is that, right? Because the coefficient for the first term is 1, so there will be no fractions in this case. But what if the coefficient for the first term equals to 2, 3, 4 or more? Then that's a different story. So what the things I'm doing here might seem very strange, right? So normally you can use these three factors to find out the one of the factor for this cubic equation. However, if you try the 6 factors here, you still cannot find the final factor that will make the whole equation equal to 0. Then you need to look at the 5th one and the 6th one. But if all of these integers from the factors of the constant term cannot be found to figure out the equation, then we use each of the factor from this constant term divided by the coefficient of the first term. That is the highest power term. Okay, the coefficient of the degree term in this case. Okay, right. So that is terminology or the concept, the logic behind it. Right. Next one, we should take a look at a different example here. So let's figure out. After trial and error, you will get a linear factor. For example, you would get x minus 1, because when you bring x equals to 1 into the equation, you will find that the whole equation becomes to 0, which means x minus 1 is a factor. Is that the place we should end? No. We only find one factor. Okay, so at this point, either you can use a long division to find out the other. Okay, so you use fx long division divided by x minus 1. Okay, and the quotient will be another factor. And it might be a quadratic factor, and then factorize the quadratic expression so that all the factors you will get should be the linear factor. Okay, so decrease the power to the lowest as possible. That's the first method, using long division after you find out the first linear factor by using trial and error. Okay? And there is another method, it's called equating coefficients. You can use either of them you like. How can we use equating coefficients to solve this problem? Well, fx equals to x cubed minus 3x squared minus 13x plus 15. So this is the original expression, right? Take a look. We just copy this one right here. Okay, it should be equal to x minus 1 times x power to the 2 Oops, I have missed a coefficient here. Ax squared plus bx plus c. Okay, what's the thing I'm doing right now? We already know x minus 1 is a factor, right? So the other factor has to be a quadratic expression. Then we write the common quadratic equation here. Okay, and do not forget to write down the ABC coefficients. Okay, AB coefficient and the constant term C. So then we are going to find out what is A, what is B, and what is C's values, right? How can we do that? We compare the constant term again. So the original constant term is positive 15, right? Afterwards, which two terms multiplication can give us a positive 15? Only -1 and positive C, right? The other terms all include variable x. So only these two times together will give us a positive 15. That's why C has to equal -15. Then negative becomes positive 15. So C is found out. Next one, how can we do A and B? So basically, we can see that for the coefficient A has to be equal to 1. Why A equals to 1? Because this is the only term after multiplication would give us the highest power. Okay? The other term, if x times A, or times A, or times A, or times A, will never give us the highest power, the cube. So, the coefficient for the cube in the original expression is 1. Then, this coefficient is also 1. So A has to also equal to 1. Okay, A equals to 1. Alright, now let's open the brackets. It should be equal to x minus 1 times x squared plus bx minus 15, right? Okay, open the brackets. Okay, let's compare the coefficients. Then we can figure out the value of b. We collect like terms. This one and this one. Okay, and then we collect still the like terms. And then b minus 1 should be equal to -3. Okay, so b equals to -2, right? Okay, b equals -2, and then bring the value of b into this one, and we can factorize the quadratic expression. Simple as that, right? Okay, lastly, what we are going to review is the remainder theorem. As for the remainder theorem, we should take a look at a different story, but it's quite similar. So when there is a remainder, Still, for a polynomial px, when it's divided by x minus c, the remainder is pc. Okay, bring the value of c for each x in the expression. Why is that? For example, you can use long division to divide this expression divided by x plus 3. And the quotient, okay, the quotient would be okay, this is the quotient, but it's not exactly divisible. So here is a remainder. Remainder equals to 2. I just tell you the final answer. The remainder equals to 2. So when you make this expression equals to 0, okay, equals to 0, then 0 times this expression would equal to 2, okay? Why is that? Because this one, in theory, would equal to x plus 3 times this one, right? Is that right? No, we still add 2 afterwards because it's not exactly divisible. There is a remainder afterwards. So it equals to a times b plus the remainder. And when you make this expression equal to 0, the whole multiplication would be 0, right? So the right-hand side would equal to 0 plus 2 equals to 2. So the original expression should be equal to 2. That is the remainder theorem talking about. So if x minus c is divided, then you can easily calculate the remainder by making this expression 0. You don't need to use long division to go through the whole procedure. You just make this one, the linear expression, equal to 0. You will find out the remainder value. It's the same theory applying just for the factor theorem. So we can also extend this remainder theorem into if px is divided by ax minus b, then the remainder would equal to p, x value is equal to b over a. Okay, so it's simply as saying the same theory always applies here. But vice versa, okay? Also vice versa. Conversely, if you already know the value of remainder, okay? If the question already tells you the value of remainder, for example, remainder equals to -3, then how can we make a new expression equal to 0? We use x plus this one, okay? We divide this expression, okay? We divide it, okay? Simply saying is that x minus -3 would give us x plus +3. So that's this sentence, this statement is telling us. And what if the remainder equals to a fraction? 3 over 2. How can we do that? We use what? Okay, so A is the denominator, is 3. AX minus B is 3x minus 2. We use this expression equal to 0. Then we can get the remainder. Okay, bring the value x here. The whole expression will become 0. Okay, and then you can use this expression to do long division or whatever you like. For example, the trial and error. Okay, so that's all for today's content. If you enjoy today's content and learn something new, don't forget to like, follow, and save it. Okay, here's the deal. If the video hits 100 likes, I'll pick the most requested topic from the comments and make a special bonus video just for you guys. See you next time.